Hello everyone, this video presents on classification of chemical reactions. And in the lower grades you have learned that chemical reactions can be classified into four major categories as combination reaction, decomposition reaction, single displacement and double displacement. In this video I will explain you about another way of classifying chemical reactions, and the learning objectives of this video includes: 1. Classifying chemical reactions as acid-base, precipitation and oxidation reduction reaction. 2. Predicts the solubility of common inorganic compounds by using solubility rules. And broadly, there are three different types of chemical reactions: acid-base reaction, precipitation reaction and oxidation reduction reaction. This oxidation reduction reaction will be presented in the coming fifth video. In this fourth video, I will explain you about the acid-base reactions and the precipitation reactions. The basic difference for these three types of chemical reaction is: acid-base reaction involves transfer of proton, precipitation reaction produces an insoluble ionic compound, and oxidation reduction reaction involves transfer of electrons. One, what is the definition of acid and base? And the definition of acid and base according to different scholars is different. The first one is Arrhenius definition. According to Arrhenius, acid is defined as a substance that will dissolve in water to produce proton or hydronium ion, and base is a substance that will hydroxide ion when dissolved in water, or OH ion. And if you see this chemical reaction, when this substance is dissolved in water, it produces hydronium ion. Due to production of hydronium ion, this substance is considered as Arrhenius acid. And when this substance is dissolved in water, it produces hydroxide ion. So due to production of hydroxide ion, this substance is considered as Arrhenius acid. Another thing is types of acid-base reactions. Neutralization reaction is a specific type of acid-base reaction in which the reactants are an acid and a base but not water, and the products are salt and water. Generally, you can write that the neutralization reaction as acid plus base, it gives salt plus water, and you can consider this chemical reaction. When magnesium hydroxide reacts with hydrochloric acid, it gives magnesium chloride plus H2O. This is one example of acid-base reaction that is specifically neutralization reaction. And bases and acids can be classified as weak and strong. What is a weak base? Weak base is a base that reacts partially or has a small extent of ionization, that is ionization of base, and its chemical reaction is indicated by arrows. These are some examples of weak bases, and its chemical reaction is indicated by the double arrow. Similarly, strong base is a base that completely dissociates or ionizes in water, and its chemical reaction is indicated by single arrow. And these are some examples of strong acid, and its chemical reaction can be explained by using single arrow. Similarly, for acids, weak acid is an acid that reacts partially with water to produce hydronium ion, and some examples of weak acid includes this, and organic acids which contain the acidic carboxyl group are mostly considered as weak acids, and its chemical reaction is explained by using double arrow. And also strong acids are the acids that completely react or dissociate with water to produce hydronium ion, and some examples of strong acid includes this. Let me explain this more in detail with diagram. You can see from here before dissociation and after dissociation, and the extent, the content of the solution. If the acid is strong and after dissociation there is no undissociated acid left over, simply the cation and anionic of the acid will be formed. But if the acid is weak, after dissociation there is a base, there is an acid left over, that is undissociated acid, besides cation and anionic of the dissociated acid. So this is the way of identifying the weak acid and the strong acid. So for strong acids there is no acid left over after dissociation, but for weak acid there is undissociated acid left over after dissociation. This will be explained more by using simulation. Let me explain this simulation for strong acid. For strong acid at molecular level, when this acid is dissolved in water, it produces this anion and this cation, but there is no molecule, such type of molecule produced from this, because this is strong acid, so it completely dissociated. But if the acid is weak, if the acid is weak, when this molecule or this acid is dissolved in water, there is some acids left over and dissociated. So you can see in the strong acid there is no such type of molecule produced in this case, but for the weak acid there is such type of molecule. This molecule, this molecule, this molecule, this molecule, this molecule, this molecule is the undissociated one, this one is this one, then this one is this one. But for generally for acid and base, for strong acid there is no undissociated acid, but for weak acid there is undissociated acid left over after chemical reaction. Similarly for strong base, you can see that there is no undissociated such type of molecule produced, but if the base is weak, there is undissociated base, this molecule, after the dissociation. In the graphical or in the graph level, we can see that for the strong acid, there is no concentration of acid left over, but if the acid is weak, there is small amount of concentration of the acid left over after dissociation. Similarly for strong base, there is no dissociation of base left over after dissociation, but for weak base, there is a small amount of base left over after dissociation. Another way is identifying strong acid and strong base by using conductivity. If the acid is strong, its conductivity seems like this, but if the acid is weak, its conductivity becomes like this. For strong acid, more light, bright light is formed. For weak acid, dim light is formed. Similarly, for strong base, bright light is formed. For weak base, dim light is formed. And for strong acid, in terms of pH value, for strong acid, pH becomes 2, for example, but for weak acid, its pH value increased. For strong base, the pH value becomes this. For weak base, the pH value becomes lower. And this is one way of identifying acids and bases based on different concepts. If you see as an example, the acid that is strong acid, if you see in the molecular level, as I have told you, what about this dissociation if the concentration is increased? If the concentration is increased for the strong acid, then the concentration of A and hydronium ion will be increased, but no such type of molecule here. But if the acid is weak acid, now here we have undissociated molecule after dissociation. If you increase the concentration, what will happen? You can see from here, this concentration of acid A minus and hydronium ion concentration will be also increased as a molecular level. You can see from here. Similarly for base, if the base is strong, if you increase the concentration of the base, only the product side of the cation and anion will be increased because it is completely dissociated. But if the base is weak, there is undissociated base, and if you increase the concentration, you can see the molecules was the base one and the product one molecule also increased. At graphic level, you can see this by taking the change in concentration. If you increase the concentration for weak base, both the concentration of the reactants and the products increased. But for the strong base, if you increase or if you change the concentration, only concentration of the products will be increased. This is the way of identifying acid and base as strong and weak. Another is precipitation. What is precipitation? Precipitation is, before going to explain the precipitation, let me explain you about the solubility. What is solubility? Solubility is a maximum concentration or amount of substance that can be dissolved under specific conditions, and it can be explained also the extent to which a substance may be dissolved in water or any solvent is quantitatively expressed. So solubility rules. There are some rules that determine the solubility. One, solubility for common ionic compounds, water soluble salts and water insoluble salts. For water soluble salts, rules includes that 1. All salts of the group 1 cations like this, including ammonium ion, are soluble in water. 2. All salts containing these anions are soluble in water. All salts of chloride, bromide and iodide are soluble in water except the cations of this. As an example, you can see example, silver chloride is not soluble in water. For this, lead chloride and mercury chloride are not soluble in water. Salt salts of chloride, bromide and iodide are all soluble in water except chlorides or bromides or iodides of silver, lead and copper or mercury. Another rule is salts of fluoride. All salts of fluoride are dissolved in water except salts of lead and group 3 cations. That means lead fluoride is not soluble in water. Another rule is salts containing sulfate ion. All salts containing sulfate ions are dissolved in water except the silver sulfate, barium sulfate, calcium sulfate, mercury sulfate, lead sulfate and strontium sulfate. These sulfates of these ions are insoluble in water. Another one is the water insoluble salts. Among water insoluble salts, salts of carbonate, chromate, phosphate and sulfide are insoluble in water except compounds with group 3 cations and ammonia. That means group 3 cations and ammonia salts of these ions are soluble in water. Another rule is salts of hydroxide ion with any anion is insoluble in water except group 1 cations and group 2 cations of this and ammonia. That means calcium hydroxide is soluble in water. Calcium hydroxide is soluble in water and strontium hydroxide is soluble in water. Ammonium hydroxide is soluble in water. Let me give you an activity. Activity 1. From this chemical reaction, which substances are precipitated? How can you identify that one? Second project predicts the solubility of the compound formed when the solution of potassium iodide and lead nitrate are mixed, and do for this chemical reaction and identify or predict the results. Write balanced net ionic compounds for this chemical reaction. This is the rule for solubility. And another thing is precipitation. What is precipitation? Precipitation is sometimes referred as double displacement, double replacement or metathesis reaction. And this precipitation is a precipitation that forms one or more solid products or insoluble or sparingly soluble ionic products, and it's indicated by the physical state S or solid and downward arrow. As an example, if this is solution, if this solution is soluble, there is no precipitate formed. But if the precipitation is formed, such type of solid will be observed. Example, if you see this as an example, if this and this chemical reaction chemicals are reacted, it forms this and this. From this you can see that this S means that solid, so this product is existed in the form of precipitated. By cancelling out the net ionic equation, it becomes like this. Similarly, for the reaction between this and this, it produces this product and this product. From this product, this downward arrow indicates that potassium chloride is precipitated. At molecular level, you can see that from this there is when potassium iodide and lead nitrate reacted, there is a precipitated form, that is lead iodide is precipitated, but potassium nitrate is not precipitated. Favorable conditions for precipitation. 1. The precipitate formation depends on the solubility of the substance in the solvent. Precipitation is a result from less dissolving substances, or precipitation is formed when its concentration exceeds its solubility and more soluble the substance, no formation of precipitation. This is all about today's presentation.